Okay, this is part 2 of our notes for 2.2. It only has 2 problems, but the video is getting a little long, so I just decided to do another short one with these 2-story problems. All right, so here we go. The sum of 2 numbers is 50. If one number is x, write an expression representing the other number. This is a concept that we use all of the time in math. So let me pose this to you, and don't write any of this in your notes. I just want you to think about these things. If I tell you that the sum of 2 numbers is 50, and if I tell you one of them is 10, what's the other one? Well, if the 2 numbers add up to be 50 and one of them is 10, I bet you can tell me that the other one is 40. If I tell you the sum of 2 numbers is 50 and I tell you that one of them is 30, what is the other one? I bet you can tell me that the other one is 20. So the question is, how are you getting these other numbers? Let's do one more. Let's say that I tell you that the sum of 2 numbers is 50, and if I tell you one of them is 5, what's the other one? Well, you're getting the other one by taking 50 minus 5, which is 45. So if I tell you that the sum of 2 numbers is 50, and if one of them is x, the other number is going to be 50 minus x. If I tell you the sum of 2 numbers is any number, so you know the total, and you don't know how it's split up. It could be 10 and 40, it could be 30 and 20, it could be 40 and 10, you don't know. So if you know the sum of 2 numbers is a number, call one of them x, and then you'll call the other one that total minus x. Very important. Highlight that. We're going to use it again. Let's go ahead and let's do this last example. Let's see. So if x is the first of 3 consecutive odd integers, express the sum of the first and the third consecutive odd integers in terms of x. So we have 3 consecutive odd integers. So let's say we have the first odd, we have the second odd, and we have the third odd integer. And we need to represent them using variables. In this case, we're going to be using x. It says that our first one is x. So there we go. We've done one of them. What is then the second one? Let's think about this. So if x is an odd integer, how do I get to the next odd integer? I simply add 2, because isn't that what happens with odd integers? Like if I have the odd integer of, 5, what's the next odd integer? It's 7. And then the next one is 9. So you see what happens? To get the first odd integer, if it's x, to get the one after that, you add 2. Okay, now how do we get to the next one? Well, I take the 5, and this time I don't add 2, I have to add 4. So this one is going to be x plus 4. If I wanted a fourth one, it would be x plus 6. Another one would be x plus 8. So the first one is x, and then to get to the next odd integer, you add 2, and to the x, to get to the next odd integer, you add 2 more to this, which would simply be x plus 4. Okay, now, what does it say to do with that? It says express the sum, remember sum means addition, of the first one and the third one in terms of x. So I want to express the sum of my first odd integer and my third odd integer in terms of x, which means I'm simply going to add the first integer to the third integer. So notice I didn't use the second integer to do my actual problem. I only wanted the first and the third, but I had to get the second one to be able to get the third one. Well, it says simplify, so I can combine some like terms. What's x plus x? That's 2x plus 4. And there we go.